Today, we're going to talk about segmental permeable pavements. Starting off, this industry doubles, if not triples, every year, and will continue to do so. 15 years from now, there's probably not going to be a commercial job that's installed, a parking lot that does not have some part of permeables in it. There's just too many benefits for it, which we'll get into today. Why are we talking about? Why is permeable pavement such a big thing? You guys are going to have to answer some questions today.
This is a hands-on demo today, remember that.
No, there is a hands-on. But why? I mean, in all honesty, why is permeable becoming such a big thing?
Stormwater problems or runoff problems.
Exactly. It's runoff problems are what we're having from increased building. We're building new streets, new parking lots, new buildings, all the rooftops, all the asphalt is impervious coverage that now, when we get a rain event, instead of draining into the ground, it's running to our waterways. With it running to the waterways, it's doing what? It's getting too much, so we have erosion, it's carrying pollutants, so we're contaminating it, destroying it. So that's why permeable pavements are so big, and the industry's growing so fast, and it will continue to do so.
Locally, guys, in Lancaster, we are part of the Chesapeake Bay watershed. Lancaster City signed a big initiative to, I don't remember the exact numbers, but reduce stormwater runoff because we are in that Chesapeake Bay watershed. So you guys will start seeing this. I see some familiar faces that we've done some meetings with the city with. So it's here, and they're looking for guys to do this stuff and do it the right way, and so it performs. So locally. And
typically what happens with that, once they start going a couple and see the benefits, they're just going to mandate it everywhere. I mean, because there are so many benefits. There's a lot of cities in North Carolina. Asheville's a big one, but North Carolina State University is doing testing all over the state and doing to test with the soils and all that. So now it keeps getting passed. In Charlotte, they're fighting it just because they haven't done one yet. But as soon as they do it, they'll start going. Chicago, I think, is up to 19 miles inside the city limits of alleyways that are permeable, and they have 100 scheduled this year. It just keeps going. So if Lancaster's already started the ball rolling, you're just going to see it keep increasing.
And from the big cities, Philadelphia right now, all businesses are getting taxed on their runoff. All water that flows off their property into the stormwater system, they're getting taxed on. That's going to start increasing to the suburbs and eventually branch out to the homeowners too. So this is something we all have to be conscious about.
So this program, we'll define we'll call SPPs, segmental permeable pavements, benefits, the components of the system. We'll go into the design layout, the construction sequence, maintenance on the system, and also LEED accredited for different projects. So here's what we're talking about. On the left, you'll see what they call pre-development, before there was stuff built or impervious coverage built. But you have ET, which is evapotranspiration. What that is water that's going to come back out of the ground from evaporation and through the roots back to the leaves and back into the air. You notice with pre-development, there's almost no runoff. It's only 5% because it drains through the ground. And then 45% of it infiltrates back in recharging our groundwater and actually cleaning the water as it does it. As it goes through the soil, it gets filtered and cleaned. When we get to post-development, you can see the big thing here is runoff increases 10 times. 50% of the water now is just ran off, sent into stormwater management systems, sent right into waterways, causing erosion, all different types of problems as well.
We're going to read, this is kind of a long description, but it's very important, so I'm just going to read it verbatim on what's on the screen. The definition for a permeable pavement system is a pavement system that captures rainwater, reducing or eliminating stormwater runoff as the stormwater travels through the system. Pollutants are reduced. The filtered water then will percolate through the soil, recharging groundwater, be exfiltrated to stormwater management systems, or a combination of both, all reducing peak flow runoff. You guys understand what that means? Normal pavement, all the water is pretty much running off, shedding off. Permeable systems, they can capture almost all the water for lower intensity storms.
And we'll go through the components and you'll see how it helps reducing that peak flow. Sustainable design, that's something you'll hear a lot about, but that's the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So we're finally getting back to where you ever hear the saying, when you go camping, leave it better than what it was before. That's what we're getting back to. When we went through the 70s and 80s and the industrial growth, we didn't care about this. Let's build as fast as we can, what we can. Screw the next generation. This pretty much is what we were thinking. And so now it's making sure we're taking care of that as we do. That when we're building, we're making sure we're not destroying Mother Nature. We're taking care of it so the future generations will be able to live off the land as well.
Stormwater management objectives, water quantity, accommodate overall water volumes and peak flow. So we're trying to deal with the biggest storm possible. We need to be able to contain that water, clean the water, and be able to exfiltrate it later on after that's been peak flow, after all that water's gone through the stormwater system. Again, the other important objective is water quality. Ensure that the quality of the water is maintained. So there's been a lot of tests, and we'll get into it a little bit further, but these systems, the stones, all the microbial organisms really eat bacteria. They eat suspended solids, nitrates, all kinds of bad stuff that you're going to get into the system, all kinds of pollution. It does a great job of cleaning that.
And here is Billy Mays. Oh, let me take a peek.
Asphalt, an impermeable surface. All this runoff carrying petroleums and heavy metals, phosphates, down into our stormwater system. Let's go take a look at a permeable pavement. I'm standing on a permeable pavement system, Permea from Techo Bloc. I'm looking for runoff. I'm in a rain event. There's no runoff. All my sediment runoff, all my petroleum distillates, all my heavy metals, all my phosphates running down through the system, filtered through the aggregate, down into the water table where they belong. A permeable pavement system, no runoff.
So this is just a quick little video showing you the difference of runoff and what the permeable pavement systems do. So we'll go through. I think there's 3 slides of the benefits. I mean, there is just a ton of benefits. Like they said before, that's why once cities in Lancaster start getting it and see the benefits, they're just going to keep adding and adding more on. It meets stormwater regulations. It's part of best management practice. The DEP here.
We met with them, was that the beginning of this year or was that last year?
Last year.
It was last year. We met with DEP. They've got a manual, probably about 200 pages long for all the stormwater regulations in Pennsylvania. There's half a page for permeable pavements in there. And that's not even written right. So they still have a lot of work to go as far as making it easier for engineers and municipalities to specify this.
Yeah, and that's what we talked with them about. It's saying, okay, you have all this. We only have half a page on it. It's not written properly. So we met with them and did a presentation, showed them all of it. And I think they update it next year. They do it every 10 years or something.
Yep.
So it'll get updated, and once that gets through, it'll help a lot more of this get passed.
Is this all of Pennsylvania or just Lancaster?
No, it's all Pennsylvania, and the reason was because of Lancaster was trying to push so much stuff. Lancaster's saying, well, they don't even recognize it, and they're saying, yeah, we do. And we're like, well, according to your papers, no, you don't. You have this much on it. And they're like, oh, we do recognize it. It'll just be updated the next time you see it. But for the whole state, it's...
So if this gets updated, it'll get updated in every municipality
There's a
there?
standard BMP manual. So there's structural BMPs. There's a standard manual that the state publishes for engineering firms and architects and all those guys to have and pull off of. I think, what is structural? I think there's 20 structural BMPs that they recognize. So.
The only problem you run into, so state mandates something, each municipality can make it more difficult. They can't make it less, as in, it's like the 4-foot wall. Wall has to be engineered at 4 foot. A municipality can't say, in our municipality, it doesn't need to be engineered at 5 foot, because that's making it easier. But they can say it needs to be engineered at 2 foot. So that's where you run into the problems, because what happens, not a lot of people are educated on this yet, so they're scared of it. So they're going to make it hard for it ever to get passed because they don't want to be the ones in charge of it failing. That's what I run into. We teach all over everywhere. When we get in front of municipalities, that's their biggest thing. They're like, it won't work, it's clay here. Well, it works in clay. There's just different systems you build to do it. So
You guys probably ran across this before too, but they all like to blame each other. You talk to the local municipalities, like you got to talk to our engineer. You talk to them, they say you have to talk to DEP. You talk to them, they say you got to talk to the municipality. So you pretty much end up running circles sometimes trying to get this stuff figured out.
Another great benefit, it reduces runoff. Most low-intensity storms, no water will leave the system at all. It lowers our peak flow volumes, which reduces erosion. Where I live in Charlotte, the development was built in 2007. On each side of my house is a culvert. So I have right-of-ways that are just drains off the road, go in behind to a stream behind my house. The stream behind my house is probably 7 feet deep. There's probably normally 6 inches of water in it. And it's just because all that water has eroded it, made it that deep. Now, when we get a rain event, we just had rain for about the last 9 days, but too heavy, it floods. My whole backyard floods. That stream fills 7 feet high because all those houses, all those roadways are ran right to those inlets, right to that stream. It just keeps getting bigger and deeper. I mean, so these permeable systems will reduce that. Also reduces runoff temperatures. I mean, think about a Walmart parking lot in the middle of summer. You drive on it and you can see that haze. That asphalt's extremely hot. Well, now think about a rain event. Rain hits that. It heats up that water and then sends it right to a waterway, stream. So it starts killing the fish, plant life, all that in the stream because of the elevated temperatures. So as it works its way through the permeable pavement system, it allows water time to cool and helps reduce the temperatures. Conserve space. Rick, you have a good story on that one?
Yeah, we did a big project up close to the Delaware River. It was about 85,000 square feet of permeable pavement a couple of years ago. I see some of you guys smiling. You'd love to have that job, wouldn't you? But it was right on the river, and there was a lot of issues with that clean water. So they needed that water to be cleaned when it was going out dumped close to the river. And another reason, they had a huge impervious coverage. They only had 20% building able in this land, so they weren't able to build enough for their depot. So by doing permeable pavements, we were able to clean the water, we were able to get more buildable space, and they had their detention area actually stored under the pavement. So it was a really great project.
So they needed a parking lot so big, but they needed a detention pond. The site didn't allow both of them, so they combined it. The detention pond is underneath the permeable pavement system.
It was originally spec'd for permeable asphalt, but they found out that the load rating wasn't enough to handle tractor trailer traffic, so we were able to get it switched to permeable pavers, so it worked out really well.
More benefits, contributes to maintaining hydraulic conditions. What that means, it's allowing the water to go back, drain through the soil, recharging our groundwater and purifying the water as it goes through.
Filters and reduces pollutants also. Like we said, the stone does a great job with those microorganisms of breaking down that bacteria and stuff that's coming through the system. Fewer drainage inlets where you're normally going to need a lot of storm drains and places to run that water. Permeable pavement, the whole pavement is a drain, so you're not going to need as many. Maybe a couple potential overflow drains just in case the water comes up too high. Reduces wastewater treatment costs. Again, you're not running all that stormwater to be treated.
Do you know what the...
It's visually more attractive than alternatives, so pavers are going to aesthetically look a lot better than asphalt or concrete, anything else like that. And it's internationally proven system. We're not just pushing this in Eastern Pennsylvania. It's all over the place, all over the world. So, and we're doing a lot of catch up as far as the U.S. as far as integrating these systems. Other countries are leaps and bounds ahead of us as far as using permeable pavers.
And this one here, I think, is important, especially to Lancaster City. They're having a lot of problems. Is that correct?
Yeah.
With it flooding. And so they built these water treatment systems 20 years ago, 30 years ago, to handle what was going to be, they thought, built. And now there's a lot more has been built. So to replace it, it's not an easy fix. I mean, it's the inlets we see on the road, which is then piped under the streets. So to fix that means rip up every street. It's in the hundreds of millions of dollars to do this. So what are they going to do? They're going to start taxing like they do businesses, residents, for the lot sizes you have, making you do permeable driveways or you get taxed on it, stuff like that, because it's such a big expense. It's not a quick, easy fix. It's, like I said, in the hundreds of millions of dollars to fix it.
The city of
or
Philadelphia,
update.
guys, their solution to this is cutting out, weaving through back alleyways, installing pipes above the original stormwater system, piping that water out to the city parks. And they were happy because it only cost them $200 million. That was a win for them.
So, and as development keeps going, you're just going to see more and more of that as well. Other benefits. Ease of reinstatement. Obviously, it's just like anything interlocking. We can pull the section out we need to if we need to do repairs underneath. It gives traffic calming. When you see those big segmented pieces and the joints in between, people automatically slow down because you're expecting it to be bumpy, and then it does make a noise. So they don't even recommend it be installed in
35, I think it's
35 miles an
is the
hour
maximum speed.
because of the sound of it becomes so loud in the vehicle of it going on. So it does traffic calming, meets the economic, social, and environmental concerns, which we'll get into. A great thing for this climate is you can install it in the winter. We're using all open graded aggregates, so they're not going to freeze like a, what do you call it here? 2A modified?
2A modified,
Yeah.
yeah, 2940, yeah.
Yep, 2940. So it can be installed. It's open graded stone. It can be installed. If it was raining today, we will still do the hands-on because you can install it in the rain. There's no saturation of the stone that we're installing when we're doing it.
There's
So it can be
fines
installed.
like there is
Yeah.
with your crushed stone.
It can be installed year-round. It actually reduces winter maintenance as well. So now, how many guys plow in the winter? How many guys do the salting with it as well? Well, this, we get the ice because it melts and then freezes. With this, as it melts, it'll drain through the system. And typically when they're doing at least commercial applications, the base of the system is probably around 2 feet. And they've done research on it, I think it was in Chicago or Wisconsin, that, and we'll get into the different layers, but the sub-base never got below 36 degrees. The base layer never got below 34, and then the bedding layer never got below 32. So it never got below freezing. So it always had the air underneath it circulating with the geothermal temperatures to actually help melt the snow sitting on top and come down through it. And you can plow it, you can salt it. The only thing you don't want to do is put like sand in it because that can clog the system. You can actually even put the joint fill material right on top of it that we'll use today to give traction and stuff, and then it'll just fill back in. So.
I got a question.
Yep.
How about if, like in the city now, they're starting to put in the melt the snow and stuff? How would this work with that? Because of the installation that they put in, how's the water level run?
You talking about a
Heated
element, a heated system? We did a showcase project a couple years with it. It's not needed as much because some of these systems you have, 2 feet of excavation. What you get is a geothermal effect. The ground 2 feet deep is a lot warmer than it is in surface temperature. So that heat will actually rise through the open system and help melt some of the snow in the joints. It's not gonna, don't get me wrong, it's not gonna melt a foot of snow on top, but.
And it's not going to do it as fast as those heated elements.
That's what I mean. When they're installing that, how's this drainage going to work with that? Because they're putting concrete over top of that and then setting the pavers.
You could lay it in clean stone. That membrane or that mat could lay in clean stone. You could put it in the open graded aggregate.
And that's what we did when we did. Yeah.
Yeah, go on our YouTube page. There's some videos on that project. I think we did it about 3 years ago, I believe.
Yeah.
So.
This is our office in Canada. Showing you can plow it, shovel it, and salt it. It's amazing photos. Some opportunities that arise. Stormwater system at capacity, which I think is what Lancaster's ran into. It just can't take the water anymore because of the development of it. You meet your impervious coverage limitations, which Lancaster's passing that as well.
Yeah, there's different municipalities in the area, anywhere from, some will give you 50, 60, up to 80% usually back on the lot. So.
And when we did a lot of install in Mechanicsburg and Carlisle, the Mechanicsburg had a lot of those. They built these huge houses on these small lots. People couldn't put a patio in their backyard once their house was built and their driveway was in, because they met their limit
I
already.
think Silver Spring and Hampton, which is over towards Harrisburg, but I think it's 30% impervious is what you're allowed. So they're saying that 70% of your lot must be vegetative. So you got to remember, just if you're installing permeable pavements, getting back that percentage, you can install or build a pool or build a shed or put whatever you want on your property. So you're just counteracting that impervious coverage.
No space for parking and a detention pond. Like, you see these big properties, they have to have, an acre for a detention area, chain link fence, weeds growing 8 feet high. All that water can be stored underneath the pavement, so that can actually become usable space for some of these developers, which is a great thing. And like Jesse said, winter installation is more than acceptable because you're dealing with open graded aggregate. What we have here is a overhead view of a typical permeable pavement system. There's a couple things too that we recommend a little bit different than some of the other manufacturers in the industry. We recommend to have an elevated curb along the outside, and that's there for a couple reasons. Number one, when you're dealing with clean stone, you can't drive regular PVC type edging in place. Just because you have open stone, you can take that spike and push it in with your palm. So you need to have either some kind of a concreted in curb or a full bed depth curb encapsulating all that system.
Because if you can push it in with your palm, you can pull it right back out so it won't hold anything. It will not do good as an edge restraint.
Yeah, go ahead.
So even that grid with edge piece on there, I used that on one job and I don't think that holds either.
It's kind of hard to work with because I know that has a memory, like when it comes rolled up. So when you try to pull it out, you got 4 guys trying to hold this thing down as you're putting pavers on top of it. So there's another system they have now. It's actually it's like aluminum type edge that has some bolts that go through it, and you actually use Geothermal instead, which might be a little bit better. That might work out better for maybe some walkways, non-vehicular traffic. But we always try to recommend some kind of a concreted in curb,
especially with any type of vehicular traffic. That type of stuff for walkways, may work. It may be too time consuming to even mess with it as well. But yeah, most of the time it's going to come down to concrete or using a precast curb reinforced with concrete or rebar behind it.
The other reason we recommend an elevated curb is because what's going to be in here behind your system could be grass, could be mulch beds, could be flower beds, could be anything. When they're doing maintenance on that, there's always the potential to blow stuff into the system. And that's the biggest thing we're trying to prevent on permeable pavement systems, is not getting grass clippings, any kind of debris into the system, because there's potential to clog that area right there. Something else we recommend is a solid, non-permeable header course along the outside. You guys ever see curbs? Where does the debris and dirt and dust and grass clippings, where does all that stuff always collect? It always collects against the curb.
Especially this time of year, leaves will just blow and get trapped right there.
By having a non-permeable border on the outside, that's tighter joint product, a lot less chance for that sediment to get into the system.
So starting off the system components, we're going to start, one, the difference between this and interlocking concrete pavement starts at the very beginning. Because typically, if this is interlocking concrete pavement, what are we doing to our subgrade soil? It's the first thing we're going to do.
Not compacted.
What's that?
Yeah, when doing standard interlocking pavements, you always compact the soil. Obviously, with permeable pavements, you don't want to compact it. You guys know why you don't compact it? What's that?
I said if you compact the water will puddle.
Yeah, it pretty much tightens up those clay particles or those soil particles, so it lowers the infiltration rate of that soil.
Yeah, when we're doing compaction, what we're actually doing is chemically tightening that and getting all the air pockets out so we can start compaction from the base up. We want those air pockets. We want that water to be able to drain down back into the soil. So we don't compact. You can also do what they call scarify, where they take the teeth of your backhoe or your skid loader and drag it back to cause grooves, which creates surface area to allow more water to drain in here.
And I think they did this on the outside project here. I think they did.
We'll pull it back and we'll get to see it. So that's where it first starts different. Next is this curbing. Depending on what you're doing, typically the curbing's not going to go down actually to the subsoil. base. It'll probably be above the sub base, depending what installation we're doing. If it's a high traffic commercial parking lot, there's a lot of ESA loads on it, it may go down that far. Probably a minimum of 12 to 16 inch curb that they put in. If it's a residential driveway, obviously it probably doesn't need to be something near that thick. A walkway wouldn't have to be that thick as well.
Next thing is geotextile. We always recommend using a woven geotextile fabric between the soil and the stone. Geotextile fabric is there for two reasons. Number one, it prevents that soil from mixing with your stone. Number two, it has some biaxial holding capabilities too, so it has strength in both directions. If you would get some minor settlement because you're not compacting that soil, it's there to help bridge those areas.
And with permeables, there's actually a third reason it's put in. That fabric, and we'll see it out here, is a filter layer. So bacteria will grow on that. There's a guy, Brian Shacklew, wrote a book years back, but on the study of permeables, and on it, that fabric grows bacteria, so now it becomes a filter layer. As the water is going through, it's going through that bacteria. That's what's eating the pollutants and stuff as it goes through.
Think like a pond filter or something like that almost. You know, you put those chemicals and you put the bacteria in for your ponds. It's kind of similar idea.
Yeah, and we'll see out there, we'll get out there, we'll see the fabric, we'll see water sitting on top of it, and you'll be like, water doesn't drain through it. We use geotextile
These guys
all the
are lying
time,
to
water funnels on. But we'll explain what's going on. And there's different types, it's important. Mirify, who makes it, I have a sample set of it. They probably have 9 different types they make, and some say right on it, just for separation, not for infiltration and all that. So you gotta make sure you're using the right type. Another thing to remember about these two, as we're talking about, this type of system is usually gonna be have an engineered draw, because the sub base changes depending on traffic and depending on what we're trying to do. So they'll specify exactly what geotextile you should use. They'll specify the depth of your sub base, if there is a sub base, and that. It's not just like your typical patio. If you're going to do residential projects here, get it done once, because your soil conditions are typically the same. So you have it, you can use it for all the driveways you do, all the patios you do. Get it done once, have it, that way you know you're installing it right for the soil conditions. Next, this is our sub-base. And this is a number 2 to 3 size stone. This is what varies in the base thickness of the installation. And what depends on its thickness is soil conditions, what type of soil we'll have on it, loads that will be going on top, the amount of ESA loads, or what type of traffic it will be. If we're trying to store water in it, we'll determine how thick we build it. I think it's probably about it, but yeah, this is what varies in the system, the sub-base.
This can be somewhat difficult to find. 2s and 3s can be hard to find washed. All the aggregates we're dealing with, we want to make sure they're washed, just because you're not putting more fines into the system. You don't want it to fail prematurely from dirty aggregate. So check with your local quarries and your suppliers just to make sure that you can get this washed. A lot of projects I've seen where they actually substitute 57 stone for the full layer instead of using a sub-base.
And if you're doing residential projects, that's probably what you end up doing. It'll probably just be a 57 base layer, maybe intermittent layer of geotextile or biaxial grid in between each to help stabilize the stone. But like Rick said, this is almost impossible. We'll go out today, see the rock they have, pick one up, and your hand will be covered in dirt. They're just hard to get washed.
Yes.
What's the percentage void space on a normal?
2s and 3s is what, 35 to 40%?
They want it to be 40, yeah, but yeah, it ranges 35 to 45. The best, I think you're allowed down to 32, but they prefer right around 40.
What is 57 then?
Same.
Same.
It's just the size of the rock. And typically, the question he asked, he goes, what's the void space, which is very important. It's typically between 35 and 45%. They want you to be close to 40, if at all possible, to allow that water in. And those void spaces is what allows us to install it in the winter and stops it from heaving and breaking down like asphalt does. Because as water gets in the system and it freezes in those voids. So it's not pushing the rock, it'll actually freeze in those void spaces, not causing it to move.
And the core you buy your aggregates from can provide a report that has all that information with
Not
the
can,
exact
has to.
void
If
space.
they're selling it as 57 stone, they have to have the report on it of the gradation. Next that can be installed is our base layer. And this is typically 4 inches, and it's a number 57 stone that they put in. There's here, what you can do, you can actually put in between these 2 layers, another layer of geotextile fabric, because we're going from a big, the 2s and 3s is probably about the size of my fist, and then we're going down to 57, which is 3/4 inch stone. So they're going to weave in between and fill that, and they'll eventually choke out. They call it the choke factor of it. We just don't know exactly what that will be. So we need to compact to get that to choke out, or we can put a layer of geotextile fabric in between it, and then we know it's not going to keep working. It's already at its choke point if you do it. So there's 2 different ways you can do it as well.
Optional biaxial grid and base. This isn't just a regular geogrid. They're specified sometimes as a geotextile with the geogrid attached to it, but this is an engineered product. If you're dealing with that, you're definitely going to have this project engineered. What that does is it provides some more structural support in that base. Maybe if you had some more load you had to deal with, additional traffic, that might be something that an engineer might include.
And then you get into bigger projects, that's something you want to look into. I had a job that a contractor did for us that was 7,500 square feet. It was just a regular driveway, not permeable. But they saved $9,000 worth of stone and plus all the labor of compacting that by getting a layer of this added. They reduced the stone by half. An engineer designed it to take it out because it just adds that much strength to it and save them that much money. I think the grid cost them $1,000, so they're up just in cost alone $8,000.
And think of that as value engineering. You might think it's expensive to hire an engineer, but if they can save you that much money on that project, it's definitely worth it. Next is the bedding course. We recommend 2 inches of number 8, which you guys call 1B, I think, around here, right? And that's going to be your setting bed. Regular pavers, you use sand. With this, you're going to use a number 8 stone instead.
And then here we'll install the permeable pavers on top.
You can only use Techo block pavers for permeable pavements.
No, I don't want to. And the pavers are not permeable. The system's what's permeable. And here is another place where it changes from interlocking. At this point, we do not do compaction because we're not seeding the stone up through. We'll actually do our joint fill material first. Once that's put in, then we'll do a run of compaction over top to consolidate that joint fill material in between those, and then we'll install more stone if needed. This is just a picture showing you how it works. Rain enters, and as you can see, so here's where we were talking about heat flow and allowing the water to cool down. You can see as the rain comes, typically if this is impervious coverage, the rain hits and is ran right through the inlet. Now it's got to drain down through all these different layers, and this has a pipe system, so it's a partial infiltration system.
Holes should be down generally,
Yeah.
or whatever the engineer says. If the engineer says put the holes up on the pipe, put them up, but typically we recommend the holes to be down. Because the water's filling from the bottom, it's going to enter the holes and then be able to flow out.
So the water will drain down through. As it's draining down through, it's passing all those rocks, so your heavy metals, the total suspended solids, pollutants are sticking to those rocks as it's working its way down. And then we'll go through all these different rocks, get down here. Some of the water, typically here it's going to be clay, so some will drain and some will get exfiltrated out. So it'll build back up and then get out to the system, which is hours later. So it stops at peak flow, helps with erosion, stops overloading the stormwater management system because of the time it takes, and also cleans it and cools the water, gives it time to cool off.
Question for
Yep.
Is there any studies on it? You say of all the contaminants that cling to the rocks. Is there any studies where they have actually ripped up old permeable and actually been able to test how much actually stays
They actually test the water as it comes out. There, I believe it's in here. Like here, this is one case study, but it shows you the different ones. Yeah, there's a huge one going on right now, I believe in Wisconsin, that there's a bunch of people involved in it, but they have the water go on. They have porous asphalt, pervious concrete, and then permeable pavers on it, and then the water enters the system, has all types of testing stuff in it, and so water comes out. You can actually view it live. You can log in. It shows rain going through it, and shows the different systems, how well it's cleaning them, and that. Yeah, but there's a lot of different case studies on the cleaning of it. Yeah.
Now that pipe that you have below, I mean, what if you don't have a place to go with that? Is that just, I mean, sometimes you don't have any place to go with that pipe.
Most systems in this area are going to have some kind of an exfiltration pipe just because we're building in clay soil. And unfortunately, clay has a very low,
Now, where do you daylight that pipe, or don't you?
It's going to have to be daylighted somewhere. I mean, it could be eventually tied into the stormwater system, but just remember, it's coming out after that peak flow, after that water's cooled down, after it's been
Even
cooled.
if it's a leach field or something, where you just get it away and dig a big pit where it can store water. Yeah, I know what you're saying. What if I can't daylight? What if I'm down? Yeah, it's that
Yeah, grades
you
come
just
off
do.
towards you in one project.
And we have on that YouTube video where they actually have all the water piped to a
Or a rain garden
underground.
or something, right?
Yeah, what'd you call it?
A rain garden?
Yeah, so they build a pump in it and send it, and then they can use it to irrigate and do all that stuff with it as well.
Some pond companies make those big aqua boxes too. I don't know if
We
you saw
have
them.
them on the
These
trail, and I'll
are-
show
yeah.
you guys when we go outside.
But they're great because they, I don't know, they're 3 or 4 cubic feet each, and there's nothing to them at all, so it can definitely hold a lot of water. You can always build
Dig a
pit.
hole, stack a bunch of those up, put an EPDM pond liner around it, and then seal that off. All that water that gets exfiltrated from the system, downspouts if it's a house, can get caught in that rain harvesting system. You can pump it back out, water flowers, wash your car, whatever you want to do.
If you're doing commercial, they'll usually typically tie it into the city's
Yeah, they'll do cisterns.
stormwater system, whatever. Yeah. Good question.
These are just some examples. You guys are all pretty familiar with the stone, but just using a common size pen just to show you the different sizes. Number 2 stone, that's going to be for your sub base. 57 is going to be your base. And then number 8, which is 1B around here, is going to be your 2-inch setting bed for the permeable project.
This just goes through the gradation size. So it's typically between 3 and 2.5 inch size stone for our 2s and 3s. 57 inch to 3/4 inch size stone. Number 8's 3/8 inch. This, go ahead.
This is all our information for all of our permeable pavers. I think Chris might have included some of the studies. Are they? They're not in there.
I
Right?
have, if any of you guys are interested in infiltration studies, I have some copies printed out. We have an independent engineering firm come in. We tested, recently just tested 4 new products. Blue, Pure, Antica, and
We did
Inflame
Victorian
for
permeable
commercial
also,
also.
yeah.
This is all right here.
Yeah, we're all
it
tested in
this.
Pennsylvania. We did all these tests in Pennsylvania.
Which is in this.
so, you know.
So a lot of times engineering companies, if they're engineering your job, will ask you what are infiltration rates. So I have all the information. If anybody wants it, there's copies over there. Grab one. Or email me and I'll send you a PDF.
There's some good data. It's got the void spacing for all the products, what the actual percentage of void is in there, which the engineer is going to ask for. Joint opening size, they're all ADA compliant joint openings. The rate of infiltration, look at Antica, 993.2 inches an hour. That's huge.
Another thing, our worst one's what? Blue?
Yep.
At 569. So if we say that's at 90% clogged, that means it's still going to take 56. If we say it's 99% clogged, it's still going to take 5.6 inches of rain per hour, which is a lot of rain. At 90% clogged, if we're getting that much rain, we should be building an ark, not building a permeable pavement.
Some benefits of segmental permeable pavement, non-freeze thaw susceptible. Just because you have all graded aggregate, it doesn't have the fines to capture that water. You don't have to worry about heaving like you would in a traditional interlocking system. De-icing salt resistant. All of our products have a de-icing salt resistance warranty. They're covered by a transferable lifetime warranty as well. able to be reinstated when some surface repairs are made. Like we talked about earlier, it's super easy to unzip, to take a few pieces out, dig down, fix it, reinstate the stone, and then put the system back together. With concrete or asphalt, that's a lot more difficult, and you're always going to see an ugly patch there.
I was just in Louisiana last week, and they had a bunch of different roadways that they put new piping in, and they honestly just cut through the concrete, replaced the piping, and then put permeable pavements back on top. Because it's open graded stone, where there's a little bit they would run a compactor over it, didn't have to worry about backfilling it, settling it, all that, and they just figured the water could just drain right down and get out. So they were making new repairs and just installing this over top, knowing if we have to make any repairs in the future, now we can just rip it right out and get to it and put it right back in. So
The big difference between porous concrete, porous asphalt, is once that's clogged, it's clogged. You got to tear it all up. With our systems, and this is the issue that we kind of fight a lot, honestly, is we get lumped into the porous concrete BMP. If you look on the DEP's BMP manual, we're lumped into that category. We're really not that system. You know, our pavers are all 3 to 4% flow through rate. So we're not a porous product. It's the system as a whole. It's those joints that are infiltrating all the water. So just remember that if somebody asks you, we're not porous concrete, we're not porous asphalt. It's a completely different program. So think of a Rice Krispie treat. You dump a bunch of dust on it, you give it to somebody and say, all right, clean all that dust out. Well, it's not going to come out, so you can't clean it out. So think of it that way. We're not that porous product that the water's going to flow through the product.
Look at blue, for example. You know where your joint is, you know where your line is, you know where you need to agitate that stone, you know where it needs to be fixed. So it's a whole lot easier to maintain permeable concrete pavements.
yeah, and that's what that life cycle costs. One of the first big case studies they did was Morton Arboretum in Chicago, which it had, I forget how many hundreds, thousands of square feet done to it. But they said they figured the life cycle cost would balance back out in 23 years because of the cost of doing the system compared to the other one. It ended up taking 7. Because this system, and we'll get into it, doesn't need maintained. We'll get into maintenance. It doesn't. When do we know it's clogged? When will we know permeable pavement's clogged? Think about it. This isn't.
When it overflows.
Well, we have a puddle.
Yeah.
Okay, it's not working. There's a puddle there. So that's really, and at that point with this system, segmental permeable pavement, we can blow that joint aggregate out because all the dirt will stick in the first half inch of it. We can blow that out, reinstate it, and now it's going to work almost full capacity again. What Chris was talking about when you get into pervious concrete and porous asphalt, they have to be maintained 4 or 5 times a year because if they clog, you got to rip it all out and then redo it. So that's the big advantage.
Not petroleum based is another huge one too. We're talking about doing all this stuff to clean the environment, to clean the rainwater, to get rid of, heavy solids, all that kind of stuff. If you use permeable asphalt, you're using an oil-based product, so it's kind of counteractive. It's really not working out.
We're all of them are ADA compliant. Actually, we're going to install Pure. We used to have Permea, and the joint was too big, so that's why we redesigned it, made it tighter, so it's firm, stable, and skid resistant. No open joints larger than a 1/2 inch. Reduces. This is for leads. Reduces the urban heat island effect. Large selection, many different applications. It's attractive looking, and it's designed to hold up to 1 million easel loads. Easel load, as I explained it in layman's terms, 50,000 easel loads is equivalent of a triaxle on a road 7 times a day for 20 years. That's the equivalent of 50,000 easel loads. So you can put that in comparison with that as well.
Maximizing pollution reduction, a couple different options. Sand filter under base. What they're doing is essentially screening in a little bit of sand just to capture what they call the first flush, or a courtesy flush, as we might like to say. Nothing. So you're going to have a bunch of fines on that stone, and as that water comes through, it's going to pull some of those fines in. If there's too much fines, it can actually clog the whole system. If there's a little bit of a sand layer, that's going to act like a sand filter on the pool and actually capture some of those fines and prevent it from clogging your system.
Subgrade, infiltration, this they'll do to check your different soils, how well they do. And there's 3 different types of systems, and we'll get into them a little bit later. But they want the soil to be able to take half an inch of rain per hour for it to be a full exfiltration system. That means a system without any pipe. It has to be able to take that. They don't want water stored in the system in that subbase layer more than 48 hours. So that's what they'll test the soil, see how long it takes for water to drain in it, and then that's where it'll determine where the pipe goes in that subbase of those number 2s and 3s as well. You can get different lab reports as well, soil maps to see where you're at.
This is a full infiltration installation. Now what you have here is no X-flow pipe. All the water that's going to be going through the system is going to go back into the soil. Typically this isn't done in clay soils at all. This is done with sandy soils.
Next, this is the most common in North America. This is what you would typically install here. Would be a partial exfiltration. It's what we'll install today. What it does is we know that the clay, depending on the different types of clay, how much water will be able to drain through it. And then it will determine where the pipe goes. So again, the water's not stored in it more than 48 hours. It can drain out and then exit the system as well through the pipe. This is just a picture of showing it. Again, yes, about daylighting a pipe. Here's it tied into a stormwater, an existing manhole that they already have, just tying the water in as well. This is a picture that's off ICPI's presentation. It's kind of interesting because you can see machines have been packing it all down. You can see the track machines. There's no fabric installed.
Is that corrugated pipe too?
You need to wrap the sides because we don't want contamination coming in from the sides as well. So, a little interesting.
Third is full exfiltration. This is where none of the water is going to go back into the soil. These are done a lot of times on brownfields where it used to be a gas station or pollution or something like that, where they don't want that water to come through and then cause more damage by pulling more pollutants out of the soil. Also, it's done when they want to reuse the water for gray water, for toilet flushing, car washing, watering plants, like we were talking about earlier. And instead of using a geotextile, they're going to use like an EPDM, PVC type pond liner essentially, just to hold all that water, just to capture all that water.
This is also done, they don't want, if you have groundwater within 100 feet of it, that they don't want it to enter because it may not be totally clean as it goes through. So they do this type of system as well. Or if it has where the water table is within 2 feet or there's bedrock, obviously none of those are going to drain. We won't have to put the pond liner in. We just know water's not going to go through. We'll need to exfiltrate all of it. And at that point, we then can compact our subbase because it's not taking water anyhow. So we'll do it for stability as we built the system, just do compaction at that point.
Question.
Yes.
Back to the infiltration systems. What's with the water not setting in there for 48 hours?
They just want it, that's the design from the ICPI. They just want it out. I think it has to do with stability.
If that soil, if that water's on top of that soil for so long and it just sits there all the time, it's going to be completely mucky and it's always going to be holding water. So repetitive traffic, there might be enough pressure that goes down and distorts the pavement or causes some settlement in there.
Limestone area is often sinkhole area and stuff. Would that play in as well?
Potentially. There's not as much runoff though. It's going to be holding the water. It's not going to be constantly flowing and running off. So I don't think there'd be as much issue there. What do you think, Jesse?
I don't think it would be.
Good question.
Here's some just different design layouts. You can see elevated curb. They did the header course. Some things to keep in mind. You probably want some type of soil control there because with the system, as we talked about with the segmental permeable pavement systems, if the system clogs, it's going to be on top that first half inch, so it's very easy to get out. What's the problem though? If we're not to that point, these joint fills aren't filled in, and we're building it and we get it contaminated then, during the construction process, and it clogs underneath, then we gotta rip it all back out. So it's very important during the construction of segmental permeable pavements, we're keeping everything clean as we're bringing it in and doing it, because if it clogs underneath, then it does gotta get all ripped back out, okay? So it's important, so we wanna keep that in mind as we're building it. I mean, here too, this road is just a dirt road, so we're sure contaminants are getting into the system. So we wanna keep those erosion control things in mind as we're doing the construction. This is a pretty neat, we did this at Showcase last year, and depending on what you voted on, you may or may not got to see it. This, I believe, is the only one in North America, and it's a gas station that's permeable pavements. The reason being is they wanted to build a gas station and have waterways by it, and knew contaminants would get in the waterways, so they said you couldn't build it. So they built it permeable, where it actually filters through here and then gets exfiltrated into another filtering system to make sure no contaminants will be in the water, and then enters the waterways. So it's the, as far as I know, the only gas station in North America that's all permeable, and it's to control when there's spills and stuff that it will go through the system and get clean before it enters the waterways. This is where you saw Favorite Pete sitting down, having his oil drip into the out of his hair and into the system.
Careful, this is
cleans
on
hair
tape.
gel too. And if you tell Pete that you're into this, I will track you down.
You're on tape, Jesse.
Oh, okay. But that's this whole project, and that one you saw Pete on, that's a YouTube video as well, or multiple videos showing you how this is our garden that if we had overflow, it can go into there, and this system actually has what we're talking about, where it has the water trapped underneath with the pond and the pump, that they can do irrigation, water the plants, all that.
This was built side by side to a regular interlocking driveway. They did it right when they did a permeable driveway. They did them at the same time. And they found out that it was like, I think 15-20% less expensive to build permeable, and it was a lot quicker too. Another residential driveway in Virginia. People always say you have to build permeable pavements level, that you can't really, build them in high slopes, but there's a couple different things you can do. You can install some dikes out of, sometimes they'll pour concrete, they'll use a densely graded aggregate like your 2A modified, and build up. Just so as that water fills up those different areas, there's 3 different containment areas almost for the water, so there's 3 different places for it to infiltrate.
Yeah.
Just gives you some options.
Where it traps it so the water is going down, not all running to one spot and getting exfiltrated. So it's actually recharging groundwater.
This is local here, right?
Yeah.
This is in Lancaster?
Where's Mill Street at? Right here? Yeah, this is in Blue Ball, I believe. Intercourse. Yeah.
You can see here, it's permeable, but they're putting an inlet, which is just for emergency cases. If we get, because typically it's designed for the 100-year storm. When we get more rain than that, it doesn't flood anything. It gets into that system, gets out as well.
Some other ideas, some overflow drains. Again, as an emergency precaution, if this system were to fill up with water, it would be able to flow out through the gaps in the curb and then go into that green area in the center. Those are some scuppers on the left, same idea.
This is what they call bioswale, biogarden. And they actually, in Pennsylvania's BMPs, have these designed for different permeable applications and actually specify what plants to use in there that can withstand the salts and stuff that can be used on the road as well and help with the water. Another thing to do on certain bigger commercial jobs, have an observation well just to see, make sure how it's draining, if there's settlement buildup, and again, test water quality.
Something here, why elevate the curbs? If they were flush and it was built in lower, that water from the ground could actually water those plants. You can see they look about half dead in the picture. I'm not the horticulture expert, but they don't look like they're doing great to me. Why running bond pattern? I mean, that's not great for traffic, really. Maybe they had to do it for machine installation. And why paint lines? You could always alternate different colors of pavers or change it that way. Why bother putting more pollutants into the system?
Sidewalks. Tree preservation, boat ramps. This tree, I think the story behind it's 300 years old. Wanted to save it, like Rick talked about. Now the water and air are getting to the roots of the tree, preserving it. This is our plant in Quebec, 400,000 square feet of inflow, which is funny because we just said don't paint lines. And we painted lines, and we manufacture pellet pavers, just so you know. And there's actually a video on it.
After almost 20 years of laying pavers by hand, I'm super excited to be using the new TB100SI by Techo Bloc, a complete standalone unit that can lay one layer 8 square feet in a second. Inflow ties those rigid units together. Come on, bring that in. This gives us the ability to see heavy truck traffic in an application you couldn't have in the past. Go ahead and fire it up. Next to me is an ATS system. Great piece of technology. We're quickly approaching 100 pallets a day per excavator on this site. They said it couldn't be done. Go ahead. But at 400,000 square feet, Techo Bloc's got a solution. That's exciting production. Only from Techo Bloc.
With that project, some interesting facts about it. We talk about people accepting the California bearing ratio, which determines how well the soil is. Permeable pavements, they want typically to be above 5. There, it's I think below 3. It's like 2.8. It's horrible soil buildup. They would not let us build it. For 3 years, we fought them and said, we can build it, we'll make it can work. Fought. And finally, we got enough engineers involved. They let us build it. We have monitoring wells throughout it that they can look and test. And last year, the city of Quebec, who fought us for 3 years, purchased 30,000 square feet to use in the city. I mean, but that's just typically how it goes. There's a lot of fight until they get to see the benefits and advantages of it. Once they do, they accept it and then start using it themselves.
You guys saw those big painted lines on the picture? That pretty much takes about 100 to 150 tractor trailers a day, plus, I don't know,
Twice what they're.
30, 40 forklifts zooming around all day carrying pallets. It's holding, stacks 6, 7 pallets high of pavers, so it's handling a tremendous amount of weight.
Yeah. And you can see, I mean, that's on a turn, so the tractor trailer's coming in fully loaded, driving that turn.
And they're always nice and easy when they drive, right? They always go slow.
So, yeah, it's doing great.
Do you guys know how many e-sols I've built for?
That would have to be, I mean, it would have to be the max. It would be a million diesel loads because, I mean, it's taken at least 150 tractor trailers a day. Yeah. Construction sequence, as we touched on before, most important part is keeping contaminants out as we're building it.
Make sure everybody else on the site knows that too, because you can leave and go away, and before you know it, somebody drove their machine over it and there's mud all over the system, and it's going to be your job to fix it. So.
Yeah, it doesn't matter. The installer is always the first one that gets blamed. It doesn't matter if you follow the engineer's spec, whatever. They're always going to look at you if it fails first, so it's important. Some of the stuff, data collection, again, you know the type of soils, its infiltration rates, have a project design. We'll then go through excavation of the system, then install geotextile fabric in between. Edge restraint will go in, depending where they want it, if it's in between our sub-base or base. We can install the base. Again, optional, another layer of geotextile between our 2s and 57s. We'll install the 2 inches of our bedding layer, number 8 stone. Install the units themselves. Make sure the borders and edge restraints are in. We'll fill the joints vibrate to consolidate, and then redo that again if we have to, once they're filled. Typically want the joints to stay down a quarter of an inch below the chamfer on the paver as well, and then post-installation inspection.
This project here, a little background, it's probably about 3,000 square feet of asphalt driveway, all running towards a garage. So they were getting all kinds of issues with water inside the garage. The garage door was stained and falling apart about 2 feet up on the bottom. So we installed, I think it was maybe about 400 square feet of permeable pavement in that one area, and it solved all the problems for this guy.
Excavate the area. Typically, you're going to go 6 inches beyond, just like we'll do on the regular interlocking. The rule of thumb with excavation pass and depth is the thickness of the base is what we want to go out past. Here, they're using a extra layer of sand for the filtration below our sub-base. Installing the geotextile fabric, you can see how they're lapping it up, encapsulating the whole thing, making sure no contaminants are coming in from the sides.
There was some waterproofing done against the foundation of the garage also. Just remember, if you're ever going against a home or a structure, be careful because there's potential for that water sitting in there to leach into the foundation. So always make sure you put a membrane up or do some kind of waterproofing there.
So what Rick's talking about, you actually should see it this year in our contractor showcase. ICPI recommends within the house that has a basement that you put 10-foot membrane in the pond liner to keep water pressure and actually slope all the water away. So as it drains, it's getting off the walls, not getting into the basement. Keep it.
So sub-base installation, your ASHTO number 3s, 2 to 3 inch clean stone, less than 5% passing the 200 sieve. Just make sure it's a good washed clean stone.
And that is a compactor on it. So there's some argument about compacting the open graded stone, whether it's 2 and 3s, whether it's 57s. I will say you need to. At least one pass through, one to make sure it helps consolidate those, squeeze them tighter together, and 2, it gives you a good layer to work off of. It levels the system out as well. This is installing our exfiltration pipe. Another important thing, keeping the pipe needs to be wrapped with 4 inches of clean stone, bottom, sides, no matter what, to make sure it doesn't clog the system.
Here's some base installation, putting the 57 stone in. Setting bed, a little bit different with regular interlocking pavement. You're usually using 1 inch outside diameter pipes and screening sand. With permeable pavement, you want to use 2 inch like fence rails, almost like what they use for chain link fence. Make sure it's 2 inch outside diameter.
Laying the units hand tight.
Avoid using pieces smaller than 3/8 of an inch wide or 1/3 size of the unit. That's just typical ICPI, standards for installation.
And here you can see they're putting a solid header course in, like we talked about. Reinforcing the edge restraint, the curbing, putting rebar in the concrete. Sweeping the stone in the joints. Then doing our compaction to get that joint fill consolidated.
And it's something you're going to have to put in your bid to come back and put more stone in. Even after you compact it, you come back, 2 months later, the stone's probably going to drop about 1/2 inch. So you're probably going to have to go back and just sweep some more stone in those joints, even after you compact.
Until you get those initial rain events on it, some of that stone's going to wash out the top layers of it. Yeah, let's come back. Maintenance.
Like we said, ensuring proper long-term erosion and sediment, ENS controls, such as a vegetated filter strip. You want grass growing or something to bind that soil as quick as possible. Keeping shedding trees to a minimum. The trees drop those little flower buds and you get all that crap. You don't want that in your system, so try to avoid that. And just look at your system, look at the overhang of the trees. Try to think ahead of time where that product's going to be going in.
Plowing. You guys do plow? So go in, you know how dirty that snow gets from scraping. And if you can, keep it off the permeable pavement system. If not, that area will probably be one of the first places you'll see clogging because you're pushing all this dirt to one spot to the car wash.
Monitoring adjacent uses, look to see what your neighbors are doing, look to see what other contractors are doing on site. You know, the guy comes in to do some topsoil, do some flower beds, and he dumps it all in your system. You don't want that happening. Just try to make sure everybody's got a clear understanding of what the pavement is.
Vehicular and pedestrian traffic flow. Make sure you know what that's going to be in the future development. Like Rick said, here's a perfect example. This goes over a couple of them. One, we're putting in a new building here. Here's the construction entrance to it. It's going right over permanent. So the traffic goes in and out all the time, right over top. The other thing about traffic use, this is impervious asphalt here. All slopes right here on it. So depending what system you want to check, this system has a better chance of clogging more than the parking lot because it's also collecting all the debris and dirt coming off of the impervious asphalt right onto it. Maintenance checklist. Visually observe the permeable pavers. I mean, in all honesty, you have it in your contract that it's probably annually, maybe biannually, you go out after a rain event and check it. That's all it's needed. It doesn't need to be maintained before that. If we don't see puddling, there's no point in cleaning the system because it's not clogged. And we know once it does clog, we can easily clean it, reinstate the stone, and it's back to working again. But again, a minor adjacent uses. If a percentage becomes clogged in your contract, you can say, I don't know, 15% of the pavement area becomes clogged. That's when we'll do the cleaning. We rent the vacuum machine, clean it out. Residential driveway, you can probably use a shop vac or a pressure washer. Blow that aggregate, get it agitated, get it out of those joints, and then clean it off it and reinstate the joint of material.
Plowed snow shouldn't be stored on the pavement. Like we said, all that filth, all those cigarette butts, everything else you're going to find in that plowed snow. Once everything melts, it's going to go right into the joints and you could have a clog right in that area. So try to store it on something non-permeable, on the asphalt or in a grass area maybe.
This is from ICPI, just a maintenance checklist they had on it. See different things, backpack low, 1 to 5 year, different things as well. Again, how to maintain these. Typically, the contaminants are trapped in the top half inch. It's 99.9% are stuck in it. So we know we don't have to worry about the system clogging underneath that. Joining aggregate can be agitated, removed, and reinstated. Once cleaned, again, it's almost at full permeability. Just saying again about porous concrete and pervious asphalt. Those have to be maintained so many times a year just to make sure they don't clog. Different types of...
There's a mechanical sweeper, just showing pretty much brushing, agitating the stuff. It's picked up and then sent up to a conveyor. That's good, but probably the worst way. Regenerative air sweeper. It's pressurizing air in along with the brushes to bring some of that contaminant and dust up. Then it's being sucked up through a vacuum where it's actually pulling it up through the system. And that's the best one, the vacuum sweeper.
And obviously this is for bigger commercial projects. You'd have to get something like this involved. Any of you guys do commercial projects? You can get lead points for doing it. There's a possibility of 5 from doing it. 3 are with the pollutant removal side, 2 are with local aggregate side as well. It's just showing you lead credits you can get the points. Again, decreasing pollution, increasing builder water use, reduce energy, conserve minerals and resources, improve indoor air quality, innovative ideas, innovative upgrades, maintenance.
Over the past few years, cities and suburbs have become larger and densely populated. Areas that used to be covered by vegetation have now been replaced by infrastructures, parking lots, streets, and sidewalks. The absence of these natural surfaces has greatly disrupted the natural cycle of water. The excessive use of impervious coverings has left cities with the challenge of managing increased runoff volumes, bank erosions, flooding, and the degradation of water quality. Today, these problems pose considerable risks to the sustainable development of cities and suburban areas. It's a serious matter that requires immediate attention and a viable solution. Permeable pavement is a simple and lasting solution that imitates the original hydrological characteristics of natural soils. Its primary function allows runoff water to percolate through its joints while being filtered by different layers of aggregate prior to returning into the soil. This helps reduce the volume of rainwater runoff, thus reducing the strain on stormwater management systems. The reduced demand on stormwater systems helps avoid overloads, debris buildup, and potential flooding. Permeable pavement improves water quality and helps groundwater recharge. It also reduces the heat island effect and can be used where vegetation is not suitable. Permeable pavement can also be an integral part of the water management system. Its use can help decrease underwater infrastructures and retention basins, resulting in an overall reduction of costs. Permeable pavement allows an increase in lot usage and building opportunities in public and private development projects. This helps governments focus on reducing life cycle costs associated with wastewater management in their municipalities. Available in various sizes and colors, permeable pavement can complement any architectural design or concept. Permeable pavement has been extensively and successfully tested as a sustainable and cost-efficient alternative in a vast array of applications. Permeable pavement is the ideal solution for cities and communities faced with stormwater management problems. Keeping all these advantages in mind, Techo Bloc has designed Inflow, a permeable pavement system perfectly and specifically suited to urban and suburban conditions. The Inflow system is perfectly designed to withstand the harshest of conditions by combining Techo Bloc's landscaping expertise and the benefits of permeable pavement. Thanks to its tongue-and-groove system, Inflow can handle the weight and vibrations common to extreme industrial transport. The void spaces of the inflow layers have been designed to hold vast quantities of water and resist ground displacements caused by ice buildup and the thawing cycle. It also reduces the need for de-icing agents. Inflow is designed to cover large surfaces, and its mechanical installation capabilities are simple, quick, and cost-efficient. Its durability and resistance to adverse conditions also make its maintenance simple and cost-effective. Inflow is available in a wide range of colors and designs that can suit any concept developed by the most innovative architects. Inflow contributes to achieving LEED certification and is promoted by the EPA as an efficient LID system. Its specifications comply with the latest standards required by cities and governing bodies. Inflow, the durable solution for your pavement. Contact us for more information.